Hi everyone. We're going to do a super quick recap of our notes from last Thursday and add on a little bit to them so that you can then practice those skills later in class today. So remember, we talked about an inverse. An inverse of a function is when we switch x and y, or domain and range. And for our trig functions, typically our domain is an angle and our range is a value. So a normal type of trig function, we get something like sine of theta equals some number, and theta is an angle in radians, and that's some value. Like, for example, the sine of pi over 6 is a half. Okay. When we're talking about inverses, we are switching the relationship. The inverse sine, which this is my notation for inverse sine, sine to the -1, or alternate notation is arc sine. Oops, I didn't mean to do that. I meant to write kind of more like I wrote up there. So the inverse sine or arc sine of some number or some value is equal to an angle. Okay. When we're doing normal trig functions, the angle is the domain or input thing, and the value comes for the range or output. In inverse trig, they switch places. So my domain values, my domain are values, and my range are angles. You're about to get a little bit of my son here as he helps me make this video. All right, so if we back up a screen, we took the original sine function, made a quick curve of it, a quick graph of it. Remember that our domain was -infinity to infinity, and our range was -1 to 1. And we listed some of our points, like 0, 0, and pi over 2, 1, and 0, pi, and so on. Usually these 5 points kind of help us build our sine curve. When we flip it to inverse sine, well, 0, 0 is not a real good example, but 1 pi over 2, pi comma 0 is more illustrative of showing, hey, my x and y are switching. And so I get the sine curve wiggle, but wiggling like this, back and forth around the y-axis instead of the x-axis. Now, we talked in class extensively about how this was not a function. We failed the vertical line test. I had my little apple wand. If I draw my little vertical line here, oops, that's not super vertically, but you can see, you know, vertical line test or pencil test. This definitely fails the pencil test. This picture has a domain of -1 to 1 and a range of -infinity to infinity. We talked in class that we would then, move that. That we would say, or that the idea was mathematicians decided, all right, one chunk to match, to represent the whole curve, a chunk with the exact same domain but a restricted range. Negative pi over 2 to pi over 2 is my restricted range for the inverse sine. If I only, seriously? Clearly I'm just as much as a geek when I do this at home. Now I see, other than my little squiggle there, definitely we're passing our vertical line test, which means every input will have exactly one output. When we translated this into actual problems, we're going to skip ahead a little bit. So we did the exact same thing for the cosine. And we'll make sure we get that filled in. And we reviewed our unit circle. But then when we got into the problems where we were evaluating inverse sines, we talked about some special things. And I'm going to make some notes of these down here in the summary. So when we do an inverse sine or an arc sine problem, my range is negative pi over 2 to pi over 2, which translates essentially into quadrants 1 and 4 of my unit circle. But when I talk about quadrant 4, here's the weird thing. I have to use kind of aliases. I have to use negative names for these angles as opposed to their positive names. So if we talk about that side of the unit circle, where we have in the quadrant 1, pi over 6 and pi over 4 and pi over 3 and pi over 2 and 0, the negative versions, negative pi over 6, negative pi over 4, negative pi over 3, negative pi over 2. Knowing our ordered pairs, for my angle families, is what's going to help me identify and solve these inverse sine and cosine problems. This will be half negative square root of 3 over 2. This is 0, 1. This is 0, negative 1. Remember, because this is a video, you can slow down, you can stop, you can rewind, and to get caught up with me as we solve problems using this tool. And I'm going to flip back and forth here a bunch. When I'm looking at the inverse sine of a half, basically it's kind of like I'm thinking sine of some theta equals 1/2. I want you to figure out the theta, but we can only answer something between negative pi over 2 and pi over 2. Now, if we know a little bit of the all students take calculus trick, since this is positive 1/2 and my only options are quadrants 1 and 4 for inverse sine, I got to go quadrant 1. Sine is a half, quadrant 1, that's pi over 6. My son's out in the backyard, making sure he's... Oh, I hear him. Okay. I think we did the rest of these in class.